Hi, my name is Daniel. Nice to meet you all. Some of you get to know you better. Nice to meet the people I've never met before. I want to talk about weaving narrative into Python code. My background is obviously a technologist. I write Python. I've written Python for a while. I want to give a special shout out to one of my mentors, Dave Lesher and Michael Goldwasser, who wrote an amazing textbook for Python that sits on my shelf next to structure and interpretation of computer programs is like classic text for me. I'm also an artist. I'm trained as a visual artist, and I'm a human, which is something that I hope I share with all of you, and we can work together on that. When we talk about what makes Python amazing, like any language, it's built around text, right? And so I want to sort of focus on this scene where we think of code as text and text as narrative. And I have an invitation for you once we get to the end. Hopefully this will be something that is enticing for you. So this talk is going to draw on digital humanities, which is maybe a foreign discipline for some of you, but it's basically thinking about things in a technology space the way that a humanities person would, whether they're a literary person or a historian or an arts person or a music person, but sort of bringing that humanistic lens to the work, and then using code and technology in service to asking questions in that space as well. And yes, there will be Python, but we're going to have some deep cuts in both theory around software as well as sort of theory writ large. So what is this code for? Let's look at some specific code examples. Let's look at this code in particular. What is this for? What does this do?
I guess maybe your traditionally a reconciliation might be you're seeing if your account balances line up, maybe.
Yeah. Okay, that's some nice inference that you're making there. You're making some educated guesses based on names of functions and variables within the system.
I would assume a ledger might have transactions, but the transactions are a separate argument.
How long do you think it took an LLM to generate this? Right?
That's up to now.
Like, it probably happened in real time.
Less than 4 seconds, bro.
The real answer, I think, is we don't really know what it does. We know that it runs, because I said it runs. The tests are green, but we don't know that the semantics of this particular function are correct. The thing that it's supposed to accomplish is what it's actually supposed to accomplish. Syntactically, it makes sense as a Python function, but semantically, it's obtuse. It is a black box of semantics. There's a little bit of maybe a few holes in terms of some of the function names, but there's a lot of opportunity for misinterpretation. And we have to bring our own judgment to bear on what those names could mean. And we have to maybe bring additional context with us. And we have actually names for this. This is called the vouching gap, where we are actually really good now at producing code, but we in general tend to, this has been a long-term trend in programming, we tend to neglect capturing understanding. And in some sense, like we can talk about this in more detail, but the code is the understanding embodied, but it's hard to write, to verify that from non-technical experts, right? It's hard to make sure that understanding stays passed from person to person. It's hard to make sure that understanding is something that stays stable through time, or that we track the change of that understanding over time. So we don't necessarily have a clear reasoning chain of our own, let alone having a clear reasoning chain from an LLM. So I want to bring in this concept of literate programming to maybe deal with this challenge that we face in sustaining understanding and in developing understanding of what we're doing, not just understanding of that the code works, but why have the code at all in the first place? And the basic idea of literate programming is that the code explains itself to humans, not just to computers. That's the core idea. The documentation of the code is interleaved, not bolted on after the fact, but it's actually woven into the actual code base. And I know that there are probably objections from some of you who've maybe been trained in clean code. We'll come to that. I'm going to lean very heavily on an appeal to expertise. Does anybody know who Don Knuth is? Yeah. You want to give me a quick summary of who Don Knuth is? Just like 2 sentences, maybe.
Really great CS author. We'll send you checks if you spot errors.
That is very true. He will cut checks for people who find bugs in the books that he writes.
Did he do LaTeX?
He developed the LaTeX language for doing typesetting. He did that in the course of writing books because he was unhappy with the typesetting systems that were available. LaTeX, it turns out, has evolved into a Turing-complete language, so it is a programming language in and of itself. But he's also, like, the textbooks that he's been writing over decades is a series called The Art of Computer Programming, which is like a set of reference tomes of algorithms and ways of solving problems that is just really well renowned. And so in 1984, he came up with this idea and wrote a whole book about it that said, let us change our traditional attitude to the construction of programs. Instead of imagining that our main task is to instruct a computer what to do, let us concentrate rather on explaining to human beings what we want a computer to do, right? And if you stop and think about this, why do we even bother writing in a high-level programming language at all? We have machine code, we have assembly code, we have ones and zeros. We could just go and flip the switches to ones and zeros directly. In fact, I think there may be some tech executive who said that LLMs are going to go in that direction. Maybe, maybe not. But the claim here is that the reason we write software at all is to solve human problems, and that the computational implementation of those is a side effect. The fact that a machine can solve those problems is a side effect of the fact that we need to describe the problem coherently to other people. When we think about this in terms of Python, Python has the Zen of Python already, right? If you can go back and think about, Python has a style guide, a set of literary perspectives that elucidate and illuminate how Python should be written and how to communicate to humans effectively. We can pull out excerpts from PEP 20 about readability counts, right? That's an important paradigm in literate programming. Explicit is better than implicit, yada, yada, yada. All of these things essentially codify that communicating to humans is important. So before we move forward, I want to introduce 2 tools that we're going to use. These are conceptual tools. They're probably not entirely unfamiliar to you, but I just want to call them out so that we're clearly on the same page with them. The first is a tool we have in our tool belt called etymology. And etymology, the exploration of the origins of words, how they grew and evolved over time, may seem like a distraction and a pedantic side quest, but scholars in the humanities have found them incredibly useful for actually driving understanding of what words actually mean and deriving real understanding of what we're describing in using those particular words. Unpacking words lets us understand the rich nuance of what they actually imply in our usage of them. The other is metaphor, right? This is actually how we think. We don't actually think in direct interactions unless you're an athlete and you're thinking in pre-verbal ways, right? Your body is reacting to some specific stimulus without translating into words. When we start introducing words into our thinking process, we start to think in metaphors. We think about this in terms of that, this in terms of this other experience, this other description that I have. And so these 2 concepts are going to be really helpful and important for us as we move forward. Let's start with the basic etymology. Text is related to textile. They're literally the same word. Texier is the Latin to weave, and it is where we get the words text, context, texture, even words like subtle can trace their roots into this idea of texier. So in some sense, writing has always been weaving. In fact, this is a bit of a side note, a footnote maybe, there are people in Central America who have been tying knots in their weaving and have actually won intellectual property protection of their traditional designs because they have recognized that they are copyrightable, that this is their work, this is their writing essentially of their culture. And this realization is actually something that we can tie directly into the history of computers. The Jacquard loom is famous in our own technology history as being the inspiration for Charles Babbage's analytical engine. It was the punched cards in the Jacquard loom that drove the creation of a particular weaving pattern and enabled programming of the analytical engine. Ada Lovelace saw this when she wrote her analysis for Charles Babbage. And interesting historical note, Ada Lovelace's father was actually Lord Byron, who was a famous poet, and the reason she was trained rigorously as a mathematician is because her mother wanted to dissuade her from the troubling influence of her poet father. So she was able to use her mathematical training as a new language and used her metaphorical thinking to realize that the analytical engine weaves algebraic patterns just as the Jacquard loom weaves flowers and leaves. So the punch card ends up being part of that trajectory of history. The punch card and the Jacquard loom defined patterns. It gets into IBM's or Hollerith's early implementations of counting machines, and the binary holes in a punch card, which if you've ever talked to a graybeard programmer, they love talking about how they had stacks of punch cards back in the day and yada, yada, yada. So this is deep in the roots of how computing worked in the mid-20th century, even into the 1970s and early 1980s. These systems were actively around and being used. Let me turn back to Donald Knuth, though, for a second, so we don't lose track of Don Knuth. He actually developed a system for his idea of literate programming called Web. And Web was a system where you could write textual descriptions and functional code and have them interspersed, and then you would run a series of functions that would, if you ran the weave command, it would pull out the human documentation in a lovely typeset document that you could get printed and published. And if you wrote tangle, if you ran the tangle command, it would pull out the machine instructions and that would get compiled into an executable program. It's a pretty amazing set of technology, right? So if we think about this and step back and why is whitespace important? Well, Python community has known that whitespace is important for a long time, that typesetting is important. Whitespace is a form of typesetting. It gives visible structure to the code base and lets you understand the code just by the shape of it, what's going on. Just by the shape of the letter forms alone is not sufficient. You need actually the structure of the code to help elucidate what's going on. The comments can also be part of that weave. We have comments that are available to us, just standard hash comments. But the weave actually created this idea of a durable artifact out of the code that you could have portable meaning that traveled with the code base, a set of living documentation that traveled with the code base. And from that, we get this idea of, I'm going to dip into humanities theory. Bruno Latour, you can impress your friends at dinner parties with your invocation of Bruno Latour's notion of an immutable mobile. This is something that, an artifact that as it travels, it's unchanged, but it still makes sense when it arrives somewhere else, right? We can think of this as specific examples in particular kinds of documents, but a literate program, I want to argue, fits this category of things. All right. In Python, when we write Python, we actually already weave, according to Donald Knuth. Most Python developers already practice some amount of the practices that he would recommend. We just don't necessarily give it those names. So let's look at what some of these things might do. Python expects us to explain ourselves in various ways. If you start with a REPL, it's a dialogue. It's a conversation with the interpreter. It's not just a calculator. It's allowing you to think out loud in code, right? Docstrings. Docstrings are intentionally created to give a why a particular set of capabilities live there. You might also give specific implementation usage details, some of the how questions might be answered as well, but it is actually an opportunity to answer the why questions that literate programming drives and loves. So here's a good example of something that, like, why have a Haversine method instead of just a great circle distance, right? Here's the why. Here's why we need this in this particular case. The why, not just the X explanation. And this is actually where I want to turn and think about AI, because AI is always looking for context. Often when it gets lost or confused, the LLMs have just missed some piece of context that may be in some other file somewhere. By having good docstrings, you're essentially giving it context in place that it can examine and have a very clear set of explanation of what's going on. Doc tests serve a similar functionality. In this case, you have the example not just as static text, but actually as a runnable test. So that's fantastic, even better. This is sort of an answer to one of the criticisms that often gets levied against documentation, that it doesn't stay in sync with the code. So we've already started knocking down some of the straw men that might come at us in this regard. Type hints, another good example of an opportunity to ask and answer why questions. We can use the annotated method here to add specific annotation to a particular type response.
Whoa, go back.
You want to go back to that?
I want to go back.
Yeah. So if you're sending an email alert, you can give a retry count, and here's your annotated. It's going to be an integer, but it's not just any integer. It's somewhere between 0 to 3 with a higher risk rate, higher levels risk rate limiting, right? So you're giving feedback to people who are consuming this type in ways that are meaningful in context.
Does it do anything interesting at runtime? Like, will it?
Try it out. Yes.
Maybe.
Yes. We will have an opportunity to maybe dig into that. So we'll put a pin in that. We've got other examples though. Basic methods like help and the doc _doc methods are gonna give you additional narrative in the REPL or in wherever you might need them, right? So the expectation is that a library that you might consume is going to have these in place because someone consuming it in the REPL, figuring out their way around it, is going to invoke these things and take advantage of them. So you can call help on a particular function, or you can call function.doc and get information about what's going on there. It essentially gives you the doc string or some additional content. We even have formats that allow you for writing straight .py files, but keeping essentially a notebook style format, which I will argue very soon might be one of the most literate ways of doing literate programming. So in this particular case, it's essentially just a set of comments that start and close with double % signs. And by doing that, you demarcate a set of notebook cells, Python notebook cells. So it's markdown plus code in a plain .py file, which makes it Git friendly. It makes it editor friendly. There's a variety of tools like GPyText, VS Code, Spider, PyCharm. They all recognize this particular syntax out of the box. And there are practices from the wider community that aren't Python specific that we can think of in this domain that we should just at least call out really quickly. README-driven development, which was a concept that came out in 2010 as a specific named practice. Obviously, it's become the norm in open source, but it's even often recommended in proprietary code bases as a way to make sure that everyone's on the same page about what you're actually working on. It starts with the narrative, and then the code follows forward after that. We talk about working with agents. Agents.md files or specific vendor variants of this pattern are essentially a README for the AI, and they can give context everywhere from a global context that you have in all applications to a particular code base, and you can build up context for your agent using these files. Very helpful.
Can you go back to the markdown?
Yeah, this one?
You guys are just closing it.
Wait.
This is just sort of coding style guidelines.
No, we're looking at the double percent sign.
Oh, the double percent sign?
You're like, okay, VS Code recognizes this. I'm just like, I need to.
You might need some extensions to make that work.
No, it's doing something.
Okay.
It recognizes something.
All right, cool. So one thing to know about the agents MD file, this is a standard now that has been endorsed by various foundations that are industry wide, and this was just rough estimates. At least 60,000 projects that now have these, probably much more. Beyond working with agents, if you're ever working in, let's say, something outside of data science or outside of notebooks sort of things, having runbooks is a good example of having good documentation for how do you actually interact with the thing? How do you actually deal with this set of automation tools that you've built in ways that your 3 a.m. self will appreciate that your 3 p.m. self wrote down? So these things are all out here, but why is literate programming not sort of a normal thing that we all know and talk about? In some very real sense, literate programming has always been an aspirational endeavor. Don Knuth made the tools work for himself, but nobody else really adopted this. I remember coming across this maybe a decade or two ago, and somebody who was an Emacs user was very heavily into this and had developed a whole practice around this and was describing this practice in another sort of meetup sort of engagement. But it's not necessarily a widespread activity. So it's not like it happened and then we lost it. In some sense, it never really happened. And so let's think about why it never really happened. Why was it aspirational? Why did this weave keep coming loose? Essentially, the biggest problem that people complain about is that you have to pay attention to both the comments and the code. And if the code is working at the end of the day, how much are you going to worry about the comments if you want to clock out and go home and spend time with the people that you care about? The comments can come back to a later day, but then they drift out of sync, and then they become less useful, and then people don't maintain them, and then eventually they get deleted. So it's a real burden, and it's a hard discipline. And over time, the culture around writing code has shifted away from it, not just in the Python community, but just in general. So where does that leave us now? Well, there are people who will advocate for things like self-documenting code. So by the 90s, there were advocates like Uncle Bob saying, just the clean code is out there. Just make the good names and small functions, and you don't need comments at all. Like the code documents itself. And while that might produce cleaner code, and there are good reasons to do it for a variety of reasons from a software engineering standpoint, it still misses this essential element of it doesn't ever answer the why question that might get scattered across various commit messages, or get stuck in work tickets, or get stuck in a stand-up conversation and never persist into any artifact anywhere. And somebody new joins the team and they have no idea what's going on, and they change a function and break everything. So over time, we picked up new techniques like pair programming. And this has certainly been advocated by the XP community, the extreme programming community. And there's definitely value in pair programming. I love pair programming. In fact, one of the descriptions of working with an LLM to write code that I often love is this is essentially like a great pairing partner who you can just drop in with at any time and pair program with. Aside from the fact that it's not really a person who you can't go have a LaCroix sparkling water with after you've written a few hundred lines of code and you need a mental break. And it does transfer knowledge about the why. It does transfer knowledge often about the how and some of the things that might get lost if you're not writing lots of literate programming, but it's not written down. So the things become ephemeral, they become tribal knowledge rather than something that's encoded. And this actually is even more of a problem when we're working with LLMs. That tribal knowledge is context that the LLM really needs and doesn't have at its disposal to make good decisions. So now we have notebooks everywhere. And in some sense, I will argue that notebooks are the pinnacle of literate programming. And notebooks are great. Notebooks allow you to interleave comments and code. But one of the downsides of notebooks, if you've ever worked with them extensively and gone through multiple iterations, you might hit this state where you go, wait, did I run cell 12 already? It got updated. Do I need to run it again? Do I need to run cell 13 through 46 before I run cell 47, which is the one that I really care about? So you get this like hidden state machine that is essentially trapped in the notebook. And you risk out of order execution, which maybe sometimes is something you want, but we tend to think of programs as having a specific flow in the document that describes how we expect them to run. And so it can definitely trip us up. There's a really great talk from JupyterCon in 2018, Joel Bruce, that describes this, that if you are working with notebooks and you want to have an argument with your coworkers about whether you like them or not, or you want to have ammunition for that conversation, I recommend that talk. Joel Bruce, JupyterCon 2018. He says, I don't like notebooks, and he lays it out. So even people who are big advocates for notebooks might have questions and concerns. This is Hamel Hussein, who worked for NBDev. He was one of the employees of NBDev, which is essentially a company that creates a suite of tools around JupyterLab and enables a certain way of working in JupyterLab. But in the January of this year, he wrote a blog post that said that not only had he left the company, that he had sort of given up on working with notebooks with LLMs. Like it just doesn't work because the LLM is expecting Python and it's getting JSON blobs instead, and it doesn't know how to deal with this. I've experienced this. I understand some of the concerns that he has. I think it's maybe valid concerns and frustrations that he's dealing with this in this regard. In fact, I will note that in generating this, I put this together using a notebook and have a separate example that we'll hopefully get to in a moment. We may run out of time, we'll see. But the notebook was straight Python. This was a notebook, right? And the amount of churn that the LLM took to generate this versus the example was very noticeably, very noticeable. We also have vibe coding now. So how much do we even care about having detailed descriptions of why? You just throw out some vibes and you get a working thing and just move on. I think anybody who's writing a good amount of Python is probably comfortable with saying that there's a place for vibes and there's a place that you need more than just vibes. And so that speed pressure that you're dealing with when you throw vibes at, and vibe coding at a solution isn't going to be something that is going to deliver long-running code with the good maintainability and all these sorts of things. But yeah, it's complicated. Basically, what it boils down to. And I'm going to lean on Grady Booch, who, in a much more serious tone, describes the whole computing history as being woven on the loom of sorrow. Hopefully, we don't dip too far down that line. But there's a whole history of computing being tied to war and other sorts of very sad things. But just because we have that history doesn't mean we need to stay there. I'm going to pull in a humanities reference here. Donna Haraway wrote a Cyborg Manifesto, which for her, by the way, is not about tech bros and it's a whole other thing. But she recognizes the ties to technology that we're tied to.
I thought about like Stafford Beer cybernetics.
Say again?
I thought like Stafford Beer cybernetics.
It's grew out of and is related to, but is wholly different. She actually hasn't disavowed her notion of Cyborg Manifesto, but she's now using a new term to describe what she's thinking of as compost. That's a whole other thread. Point being, we have these tools available. Let's figure out how to use them in some way, as effectively as we can. We can be illegitimate offspring and be unfaithful to those sorrowful origins of the tools that we have at our disposal. So at this point, like I've been peppering this conversation with notions of LLMs. Why talk about this now? Yeah, the LLMs, like they don't have anything but the ability to crank out walls of text of syntactically valid Python or whatever language you might use. But yeah, they're just going to crank out code. What they don't have is a why. We provide the why. We provide the intent. That's what's left to us. Intent and verification. Did they actually do the thing that I wanted them to do? So if we're left with providing intent and verification, what is an effective method for actually making sure that those things are in place? We can certainly talk about unit tests. We can talk about formal methods as verification. But those things still just validate that the thing does the thing in ways that we expect. It doesn't necessarily validate the intent. The intent is captured, oh, I went too far. The intent is captured in things like comments, in something where literate programming actually has an edge. The AI can generate code, it can't vouch for the reasoning, right? So thinking about how we're going to use an LLM in this context, no pun intended, we have to think about the context window. And I made an allusion to this earlier, but one of the nice things about having rich, robust comments in place right next to a piece of code that you're working with. If you're working with lots of well-architected, small, decomposed files in a code base, you can keep your context window very clean just by having all of the intent right next to all of the code. You can now have all of the semantics in place right next to the syntax and overall get better results from your LLM. Yeah, and again, this idea of pulling out etymology and dealing with text is important. The context is literally, it means woven together. And in this case, it literally is our intent woven together with the syntax of the LLM that it's generating. They have limits. We should know those limits. We should work within them. And one of the things that I get frustrated by is that when I started playing with various coding tools, I would give long descriptions of intent in their preferred interface, whether it was a specific IDE tool or a TUI running somewhere, and I would just sort of pour myself out into here's what I need, here's what I want, and I would break it down and have this specific thing, and then I would go back later and go, didn't we talk about this? I thought we had a whole conversation about this, and I realized that many of the conversations that I was having, it was not capturing the context. Compaction, auto compaction happens now in most tools, and so yeah, something you have to deal with. Having that durable record of intent.
I feel like people also have context windows. People also have context.
People have context windows too, exactly. There's also this idea of the decision shadow, what you didn't write down. So what were the alternatives you considered, things that you maybe thought, well, let's test this prototype this way, and then, oh no, that's not going to work, or oh, I like the way this works, but let's tune it here and there. And like all of those decisions that you make along the way can help guide. Let's say you come back 3 weeks later and you go, now we need to do something else. And now the LLM is trying to get you to do the thing that you said, no, I don't want to do that, right? So having that decision shadow of the ghosts of decisions past is lost if you don't capture it in some way. And you can certainly capture it in additional documentation external to the code base, but having it sitting with the code base helps the agent figure out what to do. So thinking about what does this look like, a decision shadow? Get timeout, return 30, boom. And here's with the decision shadow, 30 seconds because the upstream SLA is 45 seconds, and we tried 60 seconds in prod, but here's the PR referencing that, but there were timeouts, cascading timeouts caused by memory pressure, and here's the postmortem. You can capture all of this in situ, in the place where it matters. The code is unchanged. So go back and look at the code. The code is unchanged. The code is still just def get timeout, return 30. You could almost just call that with a const But point being, move on.
Good, that we have to be like a Git commit though.
Yeah, it could, but would you remember that in your Git commit history? Would you remember to look at it when you were updating it in the future? Some new person goes, oh, I'm getting a request to make this sit longer, and they don't even realize that they're going to break something.
Right, it's almost like utility functions, and you go update something else, and now
Yeah.
the commit's effectively lost.
The commit is, it's somewhere. You could do archaeology and find it, but you have to do an expedition of archaeology.
Commits, like Altec.
My commit, I'm just like update, fix
Yeah,
this.
and my commit messages tend to look like that. I can tell when people have submitted stuff with an LLM because it's perfectly formed sentences, paragraphs even. So Peter Nauer understood this. Peter Nauer, if you're unfamiliar, another famous computer scientist from the mid 20th century, I think he's Danish gentleman. Reestablishing the theory of a program merely from the documentation is strictly impossible. Right? You can't figure out the why from the what. You can infer it, and people are smart and good at that, but the narrative is where the why lives. This is the example. I'm going to come back to this. We'll see if we have enough time for this. I've got some coding examples that are literally producing weaving code. Let's see if I can punch through these really quickly. Before we go, though, we're running close on time. I want to leave time for questions. But Python, in terms of tooling, in terms of languages, Python is probably the most literate of all of the programming languages out there. There are other comparable features in some of the other languages for some of the things that I've discussed, but notebook-style programming as a whole is largely owned by Python. And there are multiple providers out there in that space. We could then take this idea that Python is exceptional at literate programming and recognize that there are still challenges with the notebook and try to salvage the notebook. There are tools like Jupytext that will let you pair a .py file or a .md file and translate seamlessly back and forth into a Python notebook. You could have tools like NBDyn that gives you real diffs for notebooks. Mist Markdown in JupyterLab, I'm a big proponent of. I have a whole actually set of examples of Mist Markdown in Jupyter that is really fantastic as a separate code base. And there are MCP servers that you could certainly do agent editing with, where you basically turn your Jupyter notebook into an MCP server and enable the agent to interact with it via MCP. Maybe that's the way you want to go, the way we will go in the future. There are, I think, also opportunities to evolve past this idea of Jupyter notebooks specifically and think about what we could have beyond that. This idea of percent format, I think, is a really powerful idea. You guys were able to get it working pretty quickly, just playing with it. Mist as a markdown variant is incredibly expressive. If you need printed documentation, Quarto is incredibly expressive. Marimo is a pure Python with reactive, no hidden state, Git native, yada, yada, yada. So it's a very powerful tool. These are beyond working with IPy notebooks specifically. And all of this happens to just to defend notebooks really quickly, all this happens to be running from a notebook. So we talked about pair programming, and this is sort of leaning in on this idea of passing information back and forth. Has anybody ever played Cat's Cradle or any of these sort of string games? Yeah? No?
I have.
You familiar with them?
I've never really understood the purpose or what happens in them.
Have you ever played a video game?
Yes.
What's the purpose of a video game?
Fun.
Yeah, okay. So I think you understand the purpose. I think it's just a way to play, a way to socialize with people that you have around you and like do something that is both intimate but just not. Like it's not like you have to touch each other, but it's not like you're like hugging or something, right? It's just touching hands. But it's playful, right? String figures are patterns, right, that we loop together with string, and these figures exist to exchange That's it, just to exchange. Now, the person owns the string figure, but it's collaboration. And I think, to me, that's what programming in general is about, is collaboration. And that's what literate programming is about collaboration. So let me borrow this metaphor. This is from Donna Haraway, again. Passing patterns back and forth, giving and receiving, holding the unasked for pattern in one's hand is all about this work of not just interacting with the machine, but interacting with each other. And the narrative is this thread that we end up holding together between each other. Code is text, text is textile. We've always been weaving when we write code. And the tools are not perfect. I'm not going to defend the tools as they are, but we are tool makers. That's part of the job of being a programmer, is making tools. So we can certainly help grow and evolve our tools to embrace this paradigm. This is all done in NIST Markdown. And just a quick set of credits. The images that I used mostly came from Wikimedia, some book covers along the way, fair use, some GitHub avatars, maybe a TED Talk profile picture, the Python documentary. Has everybody seen the Python documentary? If you haven't, it's worth it. It's recommended strongly. It's, I think, only about an hour long. That picture of Tim Peters comes from that. He gets to have a nice little passage in there. Full attribution is in the source code, which I will have up on my GitHub very soon. But I want to invite you all to actually go and look at my GitHub and try your hand at doing some literate programming. Find a small project to work on and try it as a practice, and tell me what you think. Give me your experience and feedback. Send me links to examples. You could send me even files. My email may filter them if they're not zipped up, but whatever works for you, just let me know. I would love to hear from you all. You guys want to do a demo, or you have any questions?
Do a demo.
Do a demo. Okay. I'm gonna.
So what happens? So I know that in the MIST they have like CSV reader. So what happens if you have a CSV with like 10 million rows?
That is an interesting question. So in some MIST, you can actually not even. This is more of a Quarto thing or a print-driven thing, but you can actually import an external CSV file, which again can have like millions of rows. But you've got additional table formatting you could do in there. That's a big problem. There's no easy answer. I think you have to use your human judgment as to when it's appropriate to bring those in or not.
Probably shouldn't have a single file with those.
Yeah. All right. So let's jump into an example. Oh, this is hard to read at this scale. All right. So just to prove that these are the same things, here is the weave draft.py. You'll notice it uses the % style. I'll close this one over here. I don't need my slideshow anymore. This is when I wish I knew keyboard shortcuts in Jupyter. There we go. Okay, so we've got % style comments here. We've got import statements. We've got some function definitions. And then I've got some invocations of those functions surrounded by various % comment blocks, essentially marked down, that is wrapping various invocations, the very literate description of what's going on here. So then let me switch over to, if you right-click on a file, the .py file in Jupyter, you can open as a notebook. And so that's what I've done in this particular tab. This is the exact same source, just rendered as a notebook. And so I'm going to explore this. This is mostly metaphor, but we're basically recreating a loom in this code sample. And we're just going to use NumPy and matplotlib to generate some images based on some weaving patterns. We're going to define some punch cards using some matrices, and then we're going to turn those into images. And so if I go through and read the code, I've got lots of comments in the code. I've got doc strings in the code. I've got markdown commentary around the code. And then I've got even comments within the code. And then I can go through and I can run it. I've obviously already run it, so this will be, I'm not going to try and run it right now. But here's a plane weave. And that's just setting up this particular matrix with a very simple, straightforward pattern that matches the plane weave. If I give it a little bit more math, a little slightly larger matrix, I can define a twill.
Also, it is 50, and we need to start getting ready for the next talk. See.
There you go. Any questions before we wrap up?
I have a question.
Yeah.
With regards to this type of method, would you, where would you put down the context? Would you do it at the beginning of the code, or would you do it throughout the code? Say, well, for example, if I'm doing a twill because in the, let's say, the upper right corner,
Yeah.
it's going to be different compared to the just a straight weave.
Yeah, I think you could do a mix of both. If you had a general one, like let's say I was decomposing this into multiple different fabric patterns, I could have a separate file for each one, and when I needed to update a particular pattern with some new nuance or needed to create a new pattern, I could bring in the foundation piece, and it has everything that it needs to implement a particular pattern, weaving pattern, and then I could go create a separate file that would have that particular weaving pattern described in it in great detail that documents sort of mathematical functions that are involved in the decisions and why this or that. So you can have a mix of both, where you have it both at the beginning, maybe if you wanted to pull from the idea of like a spec-driven development, you could even go that far and have a separate document entirely. But having the specific things that it needs in a particular focused context keeps that document as small as possible. Yeah.
I'm curious with, since AI has trouble with vouching for a reason, do you believe that there could be a possible issue with hallucinations resulting from that?
Potentially, but ideally if you've got enough context built up in that particular place, one of the things you can do, like we've got the hindsight of understanding something that Don Knuth didn't necessarily have at the time, we've got the web, right? So we have this idea of hypertext that was sort of nascent around in the 80s when he wrote Literate Programming. But we have the ability to like link to different parts of the code base, make references to this or that. We can certainly pull those things in to help mitigate some of those things as well. Other questions? No?
Maybe we can give you a round of applause.
Thank you.